Hello. So I'm starting. I think it will be a solo class today. So this is the third class, third lecture, third practice session. And this is my contact details. If somebody have to contact me personally, please WhatsApp message me. So in week 1 we had done coordinate system relative motion. In week 2 we delve in the particle kinetics. Now in week 3 we are doing work energy relation, impulse momentum relation and particle impact. But today we'll be covering mostly this particle kinetics section. We have done these two under the name of transport theorem. So we had seen in practice session 1 2D examples, and in practice session 2 3D examples. Today we will look at particle kinetics. We will solve a lot of examples. So before that I wanted to just be with course structure. So week 1 was we had little information about the dynamics, and then the dynamics is consist of two things, kinematics as well as kinetics. Then we delve into the world of coordinate systems. We looked at simple 2D Cartesian coordinates and we solved a problem of projectile. And then we moved to tangent normal coordinates or the path coordinates, and we had the similar formula which was derived from the transport theorem. Next we have examples such as slotted links, and there was a semicircular slot. Next we went to plane polar coordinates because we wanted to have a build up for the cylindrical polar coordinates or spherical coordinates. So everything was into 3D. The 3D coordinate system was defined, and there was one problem of fire truck. In relative motion we saw how curvilinear motions are there. So we also saw relative motion in non-rotating frames and relation between the rotating and the non-inertial frame and the inertial frame, that is also called transport theorem. We saw some examples related to car, bridge, bicycle. Then we saw motion of the connected particles. In that we solved some problems of block and pulleys. Then relative motion relating rotating already done. So it has the problem of airplane. Then we solve a problem of rolling wheel. In that there were wheel rolling on the circular surface, and the last eagle and mouse problem. Week 2 is all about Newton law of motion and how can we find equation of motion or Newton's law of motion equations. So we had a lot of problems consisting of pendulums, then triangular blocks, then heavy chains, then masses, mode blocks, friction, conical dish, conveyor belt, then rotating disc, and then we came to look at Earth as a rotating frame, and then how the cyclones are formed, cyclonic circulation, particle thrown vertically up in the latitude and longitude, and then focal pendulum. So week 0th assignment was released on 24th July, and then week 1 assignment was released on 31st July. So these are the deadlines, and today is 14. So week 3 assignment is yet to be submitted, which consists of mostly the particle kinetics problem, and so we'll be doing today that. I wanted to start with equation of motion and solution of problems. So what sir is teaching is the theory part as well as some problems, but how to apply that theory into the practice or the practical problem is my work. So, and let's start by what kind of questions come into this part as well as how to proceed with it. So there are two type of problems in dynamics. Type 1 is where kinematic conditions are defined or are specified, and we have to find forces. So this is straightforward This is one type of problem. The another type is where forces are specified and we have to find the motion. So in this what happens? Difficulty depends on the form of the force function. So it can be force of T as VA, time or displacement, or velocity, or acceleration. So it can be those. And the solutions are found out by solving the system of differential equation. So as compared to algebraic equations, we now are solving the differential equation. So for type 2, for simple problems, or for simple functions of this force function, we can find the closed expression. But the problem becomes very hard when these functions are nonlinear in time as well as space as well. So what happens that there is no closed form of the solution, and we have to then resort to numerical methods. So now there are two kind of motion. One is unconstrained motion and one is constrained motion. Okay, so there are two kind of motion: unconstrained motion and constrained motion. So in first, motion of the particle is determined by its initial motion and forces from external sources. What happened in the constrained motion? So motion of the particle is partially or totally determined by the restraining guides. Which is other than its initial motion and the forces from the external sources. So those restraining guides are called the constraints. Okay, so first one, as the name suggests, is unconstrained motion, so it is free of constraint. But in the later case, what is happening? All forces both applied as well as reactive. So because of the constraint, the reactive forces come into the play. So those are the additional constraints which are which must be accounted for this Newton law. Okay, so there only Newton laws are there, but here reactive forces as well as additional constraints which we call as constraint equations. So those are there. So here three equation of motion can do the trick. But in the later, the number of degree of freedoms and equations are reduced regarding to the type of constraints. So these constraints can be equality constraint or inequality constraint also, and these constraints have different forms and can be classified into non-holonomic or holonomic depending on the situation. or the cases given. So we are not going into those things as it is a part of the advanced dynamic course only, because that all comes into the contact mechanics. Now coming to the free body diagram. So all forces acting on the particle needed to be counted in the equation of motion. What do this free body diagram do? FBD unveils every force that acts on the isolated particle. So first step is to draw the FBD, and then we can find equation of motion. Now before FBD also, the choice of or the appropriate coordinate system. Because this will set as the base or the reference of whatever we are calculating. So first of all, that is to be defined, and it should be consistent. Now this treatment of the body as a particle is valid when the forces may be treated as concurrent through the mass center. So what we are doing is we are taking the whole mass and we are lumping into a point where its mass center is or center of gravity is. Now we have questions coming up. This is question 1, where the coefficient of static friction between the flat bed of the truck and the crate is it carries is 0.3. Determine the minimum stopping distance s that the truck can have from the speed of 70 km per hour with the constant deceleration of the crate is not to slip forward. So let's first study the whole scenario. So we have this truck and so first let's draw a surface. Let's take this as a surface on which this truck is traveling. Let me change the color to some gray. Okay, so this is that surface where truck is traveling, and okay, so let us bring that truck back. Let me remove the markings. So this is a truck. Okay. Okay. So this is a truck and going like this, and then suddenly it kind of break at this point. Let's say the truck breaks at this point, and then it starts to stop. So it was here, and then suddenly, like before that it was just going to this full speed, and then suddenly it stops at some point. Okay, so let's say that some point is somewhere here. So that was breaking point, and this is stopping point. This is the full picture, this being the breaking point, and this being the stopping point. Now if we draw this truck as a FBD, we will have this. Now the condition is like if the crate is not to slip, okay, because here the coefficient of setting friction between the flat plate, so this is given as mu static 0.3, and we have to find the minimum stopping distance that the truck, so that s we have to find, so let's denote this as s. Now this s we have to find, so at this point the truck had the velocity of 70 is it kilometer per hour? Kilometer per hour. Now it is having the constant deceleration, and if the crate is not to slip forward, okay, so no slipping allowed. So let me write that down, no slipping allowed. So we generally take G as 10 and mass of the truck is 10. So we have different scenarios. What are those scenarios? Okay. If crease is not to slip, means that friction okay, here I have made mistake. This is not mu s here, it is actually mu s here. So now we have to find minimum stopping distance. Then x direction is equal to max. So if we look at that, it will be minus 0.3 mg is equal to ma, and ax, it gives ax is equal to minus 0.3 g. So we are assuming it to be constant for minimum distance. Now using v square is equal to v naught square plus 2a s minus s naught, we get 0 is equal to 70 square, 70 into 10 by 36, since it's in kilometer per hour, plus 2 into minus 0.3 g into s. Okay, now this gives us s is equal to 64.2 meter. Now the thing is, if the truck comes to the stop from the initial forward speed of 70 km per hour in a distance of 50 meter with a uniform deceleration. Okay, now determine whether or not the crate strikes the wall at the forward end of the flatbed. If the crate does not strike the wall, calculate its speed related to the truck as the impact occur. Use the friction coefficient mu s equal to 0.3 and mu k is equal to 0.25. So taking same photo, not working properly. Okay, taking the same photo. Now we know that stopping distance is 50. This s is equal to 50 meters. which is actually less than 64.2. Okay, so therefore we can say that crate is slipping. Because that's the limit. If it is longer than this, then there will be less deceleration, but here deceleration is more, which gives that it breaks the limit, hence crate slips. So now using v square minus u square, or v square is equal to v naught square plus 2a s minus s naught. So using this formula we get acceleration of the truck into 50, not 64.2, 50. So this will give us the acceleration of deceleration of the truck, because since it's negative, minus 3.781 meter per second square. Now using the other formula, v is equal to v naught plus a into t minus t naught. This will give us t stop, or time at which it will reach the t stop, so which comes out to be 5.14 second. Now we know that friction force Fs is equal to 0.3 mg, which is equal to 2.943 m, and this is static friction. Kinetic friction will be equal to 0.25 mg, which is equal to 2.45 m. Here m is not meter, the mass. Let's say we are assuming that crate and trucks are going side by side. That is a of truck is equal to a of crate for some part. So using f of x is equal to max, using this formula we get so this is the required friction. Which is equal to m 3.781 m, and it is greater than the f of s. Therefore, the crate slips and F is equal to Fk acts, the kinetic friction. So minus F of Fk is equal to Ma crate, which is where A crate now comes out to be minus 2. Minus 2.4. Removing the mass. Now if we say acceleration of crate as compared to truck or respect to truck, so if you wanted to find out this, so if you want to find out this relative acceleration, so this can be done by simple relative motion formula. So actually, instead of deceleration, the crate will now experience an acceleration in the forward direction. Okay. Therefore, the crate slips forward. Now question is, will it strike the wall? So wall is at 3 meters from it. So the question is, will that strike the wall? Now using S is equal to S naught plus V naught T minus T naught plus half A T minus T naught square. So we are kind of finding the relative motion calculation. So this gives us 30 is equal to half into 1.331 into t square, which gives us t strike at which it is moving 2.123 second, okay, which is less than t stop. Therefore, crate will strike the wall before the truck stop. Now did you find everything? Calculate speed relative to the truck as the impact occurs. So we still have to find one thing, which is relative speed. So let me create some space around here. So let me create some space around here. We still need to find the relative velocity. Oh. Okay, now we are finding that relative velocity by using formula v is equal to v naught plus a into t minus t naught. When we apply this, we get v of rate with respect to the truck relative velocity, which is equal to 0 plus the relative acceleration is 1.331 into 2.123, and which comes out to be 2826 meter per second in my notes. Okay, so this complete our we'll say question 2. Now coming to question number 3. It says if the coefficient of the static and kinetic friction between 20 kg block, which is A, and 100 kg cart, which is B, are both essentially the same value of 0.5. Now determine the acceleration of each part for let's say P is equal to 60 Newton and then P is equal to 40 Newton. So this 3 has two parts, 3A and 3B. So here is that I need to paste. Okay, let's solve for A, which is when P is equal to 60 Newton. Now we can see in this figure when P is equal to 60 Newton, we have NA is equal to 20 G, F max is equal to 0.5 NA, which will be equal to 98.1. So we can say this, that N is less than 120 Newton. Therefore this block A, it moves forward relative to B. And if we apply this force balance, so this will give us 120 minus 98.1 is equal to 20 acceleration of A, which comes out to be 1.095 meter per second square. Now 98.1 is equal to 100 AB. So this gives us the value of acceleration of B as 0.981 meter per second square. Okay. Now part B, which says that P is equal to 40 Newton. So here F max comes out to be greater than the 80 Newton. Therefore, block A does not move related to block B or the cart. A and B move together. So this is 80 into 120A, where A comes out to be 0.667 meter per second square. Now you can find the developed friction by isolating FBDs at A or B. So which comes out to be 80 minus F is equal to 20A. F is equal to 66.7 Newton, which is less than F max. So assumption is valid. So F come out to be 100 A. So this complete of question 3. Now moving to question 4. Taking a short break. Okay, let's continue. So in next question we have a simple pendulum which is pivoted at O, and it is free to swing in the vertical plane of the plate. Now if the plate is given a constant acceleration A up the incline theta, write the expression for the steady angle beta which is assumed by the pendulum after all initial startup oscillation have ceased. Now we have to neglect the mass of the cylinder supporting rod. So very tough question to design. So we have this steady state FBD. So when everything is steady, vibrations are died out. So this will be the case. Yes, you can make a correlation between them. So now coming to only this FBD and balancing the vertical forces or force in the y direction, we get the equation T cos beta minus mg cos theta is equal to 0. And when we balance force in the x direction, so here max so this will give us T sin beta minus mg sin theta is equal to ma. So we can find beta using these two relations. So we can divide the equations and we can easily find this beta angle. So this completes our question number 4. Now coming to question number 5. Now here we have two blocks, and for the friction coefficient mu is equal to 0.25 and mu k is equal to 0.20, we have to calculate the acceleration of each of the body and the tension T in the cable. So again, drawing the FBD. Now first of all we will write out the short relations such that, so let's take the whole length be L. So S, so this, let's say SA, then SB, SB again, plus C plus L. So this will give us SA plus 2 of SB plus C is equal to L, which directly gives A of A plus 2 of A of B is equal to 0. Now as you can see, N is equal to 60G cos 30 degree, M and f of max is mu of S of this N, which comes out to be 127.4 Newton. We assume motion impends at block A. So this gives us F is equal to F max. And equilibrium will be (60G sine 30 degree minus F of F max minus T is equal to 0. So this gives us T is equal to 166.9 Newton. But this cylinder B will not be in equilibrium. Since 20G minus T 2T is less than 0, so it is moving up. Now assuming block A slides down, so block A slides down and block B moves up. So this gives us A as AA and is equal to 120 AB. This is first equation. Twenty G minus 2T is equal to 20 AB, which gives us T is equal to 105.35 Newton and AB is equal to minus 0.725. So it's a deceleration meter per second square, and AA is equal to 1.45 meter per second square. So this completes our question 5. Now moving on to question number 6. So it says that a bar of length L and negligible mass connects the cart of the mass capital M and the particle of mass small m. If the cart is subjected to a constant acceleration a to the right, what is the resulting steady state angle theta that the freely pivoting bar makes with the vertical? Determine the net force P, which is now shown here, that must be applied to the cart to cause the specified acceleration. So the cart is moving with acceleration a, and drawing the FBD look like this. P by G. On the x direction. So this will be the equivalent force. So now starting question number, which one was the previous one? 6, 7. Here it's asked that determine the acceleration of bodies A and B and tension in the cable due to the application of 250 Newton force. Neglect all friction and the masses of the pulley. So instead of 300, I think, so it is 300, sorry. So this is our FPD. So before going that, we can first write the relationship. 2 of S of A, like how much A will go, plus 3 of S of B plus C is equal to L, total length, and which corresponds to 2A of A plus 3A of B is equal to 0. Now taking force in the horizontal direction, so these are the two equations, and from this A can you find out minus 2.34 meter per second square. B can be found out as 1.56 meter per second square, and T can be found out 81.8 Newton. Okay, using three equations. So this is first equation, then this is second equation, this is third equation. Okay, three equation, three variable. Now solving for question number 8, I think. Question number 8, what does it say? So we have the slider A and B, which are connected by a light rigid bar and move with negligible friction in the slot. Now both of which lie in the horizontal plane, and for the position shown in this question, the velocity of A is 0.4 meter per second to the right. Now determine the acceleration of each slider and the force in the bar at this instant. So we'll be needing FPD. So here is those FPDs. Now this is kinematics. Kinematics. So the triangle OAB. S of A is equal to S of B, and 0.5 equal S of A cos 15 degree plus S of B cos 15 degree. So this gives us that S of A is equal to S of B is equal to 0.2588 meter. Similarly, L square is equal to S of A square plus S of B square minus 2 SA SB cos 15 degree, or cos 150 degree, sorry, cos 150 degree. So if we can differentiate it, with respect to time, L square is constant and it will be 0. SA will be 2 SABA plus 2 SBVB minus 2 cos 150 degree, and here SAVB plus SBVA. Okay, lost connection. Waiting for the connection. Okay, we are back in action. So differentiating with respect to time will get us this, and we have given that v of a is equal to 0.4 meter per second, v of p is equal to minus 0.4 meter per second. And if we differentiate it again, we will get 0 is equal to, from now here it will be a square plus SA A. So like one term has converted into two terms now. VB square plus SB into AB minus cos 150 degree into SA AB SB AA plus 2 VA VB. So this will lead us 0 is equal to 0.04287 plus 0.4829 A of A plus 0.4829 A of B. Now coming back to kinetics. T minus T cos 15 degree is equal to 2 A of A, and T minus T cos 15 degree is equal to 3 A of A of P, and we are putting this into 1. So this gives A, this is 1, this is 2. So from equation 1 and 2 we get the final values. So this is actually 2 is this is 3, and first equation is this. Now moving on to question number 9. Now with the block initially at rest, the force P is increased slowly from 0 to 260 Newton. Now we have to plot the acceleration of both masses as function of P. So all the data are given, and this is our scenario. Now whatever is given, I will first write that. Na is given as 35 G, and B is given as Na plus 42G, which is equal to 77G. F of A max is equal to 0.2 Na, which is 68.67 Newton. F of P max is equal to 0.15 Na, and B, and this comes out to be 113.3 Newton. Now Fa kinetic is equal to 0.15 Na, which comes out to be 51.5 Newton. Fbk is equal to 0.1 Nb So now there are three possible situations. So first is no motion, then B as well as A, B and A move together, and B and A move separately. Now I want to mention two impossible situation also. Those are B moves alone, because what will happen, since Fa will not be equal to 0, so A will move eventually, and second is A moves alone. This is case P1, P2, P3. This is I1 and I2. So why A moves alone? Since a P is applied at block B, and it forces So now starting with case 1, we say that P is in between 0 and FB max. So what will happen that FB will be developed which will cancel with the applied P. FA will stay 0. So there will be no motion. Such that A of A will be 0 and A of B will be also 0. So this is P1. Moving to condition P2. Now let's assume both A as well as B go together. Okay, so therefore f of A is less than equal to f of A max and f of B is equal to FBK. Okay, now balancing the force, this will lead us that f of A is equal to 35 A and P minus f of A minus f of BK is equal to 42A. Now at P is equal to P min is equal to F B min P max, which is increased slowly A is equal to 0.49 meter per second square. So this gives FA is equal to 17.16 Newton. So it's like jumping. Now at F A is equal to F A max, it is just about to slip. P is equal to 226.6 Newton and A then becomes 1.962 meter per second square. Now between these extremum values, A will be is equal to P minus FP by 77. So this is the linear function of P. Therefore FB max will be less than P so it will be between the FB max and 226.6 Newton. So here what will happen, that AA is equal to AB, which actually varies, linearly from 0.49 to 1.962 meter per second square. Okay. Now next we had done P2, P1. Now coming to P3. Which says A slides, that too backward. Relative to B. Since increasing P makes B. So this is the reason why A slips. So f of A is now f of A kinetic, and this gives us f of A kinetic is equal to 35A, and P minus F P minus F A kinetic minus F of B kinetic is equal to 42 AB. So this gives us A is equal to 1.47 meter per second square, which is constant, and A of P equal to P minus 127.04 by 42, and this is also linear function. So therefore 226.6 to 260, we have A is equal to 1.47 meter per second square, which is constant, and then 2.37 to 3.166 meter per second square jumping. Okay, how all will look like? It will be something like this. A of A up to some point it will be 0, and then it will start let me mark it by some other color. So from 0 it will be from 0 to at this point, and similarly B, equation of B will be also something like this. Then there will be a jump, a sudden jump, denoting this jump. Then there is a linear relationship, and after that again a jump, and then this become constant, but this keep on increasing to 3.7. So we'll end here, and we can discuss next class. So this marks the end of this lecture. This is 36-page document. Okay, I will share this. it is not working. No, it's lecture number 3. I think we time still 2 minutes left. So what I will do meanwhile, I will set for next class. Now this week 3 will become week 4 somewhere here. That we will do afterwards. Okay guys, thank you for paying attention. I'm stopping the recording.